Hi everyone, and welcome to our video on shifted circles polar graphs. So these will come in the form of r equals a constant times cosine of theta, or r equals a constant times sine of theta. Okay, so it's our not much going on with them forms. Now, one way to break these down is purely memorization if we want to. However, the other way to do these problems that I think that can carry over well for other scenarios is let's graph it using the rectangular, just so we didn't convert it. So remember, okay, so if we had gone back a couple videos, we can convert equations. So this isn't converting this equation into this. I just want to see the rectangular graph with the change of variables, with changing r into y and theta into x. And so I'm going to graph that right here. So this method does require us to remember how the cosine and sine graphs need to function. And again, I think it's good review anyway for those. But the cosine graph has the amplitude of 4 in this problem, and then the cosine would go something like that, where we've got here is 2 pi. The bottom peak is pi. So if you divide it by 2, you get this. If we divide it by 2 again, we get pi halves. And if we times it by 3, we get 3 pi halves. Okay, so this is our x and y for this rectangular graph. However, what I need is a polar graph. Okay, so polar over here. Again, I'm going to mark my angles. So there's 0 pi halves, pi, 3 pi halves, and then all the way back around at 2 pi. All right, so we're going to use the sketch over there to state, well, we said r is the same thing as y, so I'm going to say, well, these are our r's. So these are our radii, and then we're going to plot our points down, and then, actually, let's keep it. This x we're saying is theta. So remember our r and theta, we can make a table out of this as well, or we could have even started with the table. But this graph helps us find some values pretty quick. Okay, so for instance, I have 4, and then theta is 0, so that's that first point. And then this point, my radius is 0, and my angle is pi halves. And let me scroll a little bit. Then my bottom peak is, the radius is -4, and angle is pi. And then we have back to radius of 0 and angle 3 pi halves. And then the last one, I have a radius of 4 and 2 pi. Okay, so there's my table from it. Okay, and now it is plotting points, but we do go in the order. So this is our first point, second point, third point, fourth point, and fifth point. And then we'll connect those dots. Okay, so I'm going to say, let's go 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so my radius is 4 and the angle is 0. So that means I'm again, you start with the angle. So I'm looking at 0 and then I want to go 4 toward it. Okay, so that would be, let me do it in blue now. That would be right there. Okay, so we've got the first point plotted. And then our second point, we have the radius is 0 and then our angle is pi halves. Well, if the radius is 0, we're automatically at the origin or the pole in our polar function, in our polar graph. Okay, but we want to figure out, well, how to get from this point number 1 to this point number 2. Well, that's where this other graph comes in. Notice I would have all of these angles being in quadrant 1 with positive r. Well, here is quadrant 1 in our 0 to pi halves, and then positive r means all of those points would be plotted somewhere in quadrant 1. So that means connecting these 2 points, I would need to do it with an arch through quadrant 1. Okay, so something like that. Okay, and then, so we plotted our first point, second point, our third point, or maybe I should do check marks because it's a little tough to see, but our third point, we have the radius is -4, the angle is pi. Okay, so here's angle pi. Here's where positive 4 would have been. -4, though, would put us back to where our first point was. Okay, so I've got that plotted, and I'm just labeling it 1, 2, 3. Our 0 and 3 pi halves, that again has a radius of 0. That means it's back to the pole. All right, so let's figure out how do we go from step 2 to step 3. Well, from step 2 to step 3, and it might also help to label these as well. So there was our first point, there was our second point, here was our third point, fourth, and then that will be the fifth. Okay, so from step 2 to step 3, I'm in quadrant 2 now, and all of my radii are negative. Well, quadrant 2 is here. It means positive radii would have been plotted in quadrant 2, but negative radii would go to the opposite quadrant. So that means to connect point 2 to point number 3, I should graph through quadrant 4. Okay, so I would have had, let me put it here, quadrant 2, but negative radii should mean I should be plotting in quadrant 4. Okay, and then to figure out how to go from point 3 to point 4, and point 3 to point 4, point 3 to point 4 is in quadrant 3, so here it is. But again, I should have negative radii, negative r. So positive radii would have been plotted in quadrant 3. The negative radii would be plotted in quadrant 1. So to get from point 3 to point 4, I'm following this top arch again. So it's just repeating itself. Okay, and then the very last point, 4 and 2 pi. Well, here's the angle 2 pi. 4 and 2 pi would put us right back again at that initial point that we plotted. And well, to get from 4 to 5, I would be in quadrant 4 with positive radii. So that means they should be plotted in quadrant 4. So from 4 to 5, I would be following this arch again. And I'm trying to just bold like that. So we get a circle. The circle has radius of 2. So we can see there's the center. Or you could say the diameter is 4. So you could say, oh, that information right there is the diameter. And then what can help in these problems to speed it up, so you could just say, well, that's the diameter, and then cosine's related to the x. So notice our circle has the important intercepts on the x-axis. Or so that's one way to break it down. Okay, so that's how we can do these. Now let's speed this one up or show it in a different way. All right, so I want to graph a polar graph. Again, I'm just going to label my angles as such. Well, if we take what we just said on that final step right here, where I said, oh, it's a diameter, and then the cosine function tells me to go something with the x, well, this could say that should be a diameter, and then the sine is saying I should do something with the y-axis. The negative is probably telling me to reflect. So for instance, like on our previous cosine graph, it was to the right. That's because it's a positive 4. If it was a negative 4, we would have had a circle. I'm going to make a really tiny sketch. Would have been something like that. So this would have been r equals negative 4 cosine of theta. Okay, so on this second one, we could say, well, it should be something with the y. The 5 is the diameter, and then the negative is telling me kind of where to put it. So a positive y, I would think, should put me here as a circle. The negative 5, well, should be down here. Okay, so we would have 1, 2, 3, 4, 5, and that would be it. Okay, so that's the very quick way to have done this problem using just the reference from before. Now, again, if we don't like that, here, let's just make a table for this one. So if I'm only making a table, so we're going to check our answer on this. Okay, so just to verify. So our theta is what we would really want to start with first. So 0, and I would just do the main axes angles. That's probably good enough for these problems. Okay, so there's our angles. And then the radius is to plug those values in. So for this first one, I'm just putting arrows since I'm running low on room. It would have been doing negative 5 sine of 0. Let me fix that 0. So we're just plugging in the actual angle, and well, sine of 0 is 0, so times -5 is 0. If we did plug in pi halves into our theta, that would give us -5. If we plugged pi into that theta, we would get 0. If we plugged 3 pi halves in, it would simplify to be 5. And if we plugged 2 pi in, it would simplify to be 0. Okay, so same deal. This is our first point. That would be right there. There's point number 1. Our second point, we're looking at the angle. Angle is pi halves, but -5 is telling me go the opposite way. So don't go 2 pi halves, go the opposite way, which would be down here. So there is that second point. And then the way we would have gotten to it is just following along the arch. Okay, so we have 0 to pi halves would be in quadrant 1, but it would have been negative angles, negative r, or negative r's, not negative angles, negative r, which means really those points would have been plotted in the opposite quadrant to get to the axis point. Okay, and then our third point is back to the origin, back to the pole. Okay, so there's our third point. Between pi halves and pi would have been in quadrant 2, but it still would have been negative r. And so negative r would have been plotted in the opposite quadrant, quadrant 4, to get back to that original pole. And then after this, it just is going to repeat itself. So we could plot these other ones as well. It would have been 4, it would have been 5, and they would have followed the same path over and over and over again. Okay, so that's it though. Okay, so you could, if you want to just think of the circle and diameter, I mean, that's fine, because you could do these problems a lot faster, but I think breaking it down with the graph can be useful for the couple problems coming up. Okay, so thanks for watching. If you have questions, let me know. See you again next time.